In this video, we will discuss about the concept of compressed versus rarefied gas and also subcooled versus superheated gas. So here I have shown the PV diagram and the TS diagram. So we have already seen how to plot a PV diagram of a pure substance. So here I have drawn the PV diagram. So inside you can see that is liquid plus vapor. Here it is liquid and here it is vapor. Similarly for TS diagram, here you have this liquid plus vapor, here vapor, and here you have the liquid. You are mainly concerned about the, we will focus on the liquid vapor transformation. So let us try to draw an isotherm here. So isotherm means at constant temperature. So let us start from here. Okay, so you can see that this is a superheated vapor state. Okay, so that means if you want to cool it, that means if you are trying to reduce the specific volume, so you can see reduce the specific volume at constant temperature. Okay, so that means at constant temperature, if you want to reduce the specific volume, you need to increase the pressure. That means you need to compress the liquid. So that is what I am doing here. So you can see that from here to here I am increasing the, from here to here I am increasing the pressure. When I am compressing the gas, it will reach the saturated state, that is the saturated vapor state. At this state, so that means if you again reduce the specific volume, okay, so you can see that from here the pressure remains constant and also the temperature also remains constant, that is during the phase change process. So during the phase change process, you have the temperature, that is called the saturation temperature, that will be constant, and also the saturation pressure will also be constant. Okay, you can see by compressing at constant pressure, you can compress it, you can reduce the specific volume, right? This is at constant temperature. This is for T is equal to constant. So again, if you want to compress it, see, it has become a liquid. So that means if you want to compress it, so that means you need to apply very high pressure because it is a liquid. So and this liquid is almost incompressible. That means if you want to change the specific volume, reduce the specific volume, you need to apply enormous amount of enormous amount of pressure. So that means, so the curve goes like this. This is a constant temperature compression. So this can be, so if you are doing this for a different temperature, so this is T1 and this is T2, you will get a graph like this. See, okay, you will get a graph like this. Okay, this is how you plot the isotherm in a PV diagram, right? Now we have understood how to draw an isotherm in a PV diagram. So let us see what is the concept of compressed gas. So let us take a state point here. See, let it be here, right? So that means, so if you want to convert it into liquid, so if you want to bring back to it to its saturated state at constant temperature, then that means you need to increase the pressure. So if you are increasing the pressure, you can reach the saturated state. That means you are actually, what you are doing, you are compressing. Okay, you can you need to compress the gas, okay, to reach saturated state. So the gas here, see the gas here, this portion is called rarefied gas. It is called rarefied gas. That means the rarefied gas means you need to compress it. You need to add additional pressure to reach the saturation state. So that is why it is called the rarefied gas. So rarefied means how far it is different from the saturated state. Saturated state. So that means what is the difference? The pressure. That means from that state you need to apply a lot of pressure. You need to compress it, right? So it is called a rarefied gas. Now take a state here. Okay, so at a constant temperature, if you want to reach the saturated state here, okay, you need to reduce it, reduce the pressure. Okay, you need to reduce the pressure for here in that state. Okay, so that we will call it compressed liquid. Okay, so that means compressed liquid means the liquid at these states. So if you want to reach the saturation state, you need to reduce the pressure. Okay, so that means pressure need to be reduced to reach saturation state. Okay, or the saturation pressure. Okay, and that kind of liquids are called compressed liquids. So this is the difference between compressed liquid and a rarefied gas. So that means it shows the difference in pressure between the saturation pressure and the real pressure. So let us take the TS diagram now. For a TS diagram, we will plot the isobar at constant pressure lines. So it will be drawn like this. Okay, see, these are the different constant pressure lines. Okay, these are the constant pressure lines. So that means let us take a liquid a substance here. So that means if you want to reach the saturation state at constant pressure, that means this state, you need to reduce its temperature. Okay, temperature needs to be reduced. So that is why that state is called the superheated vapor. That means for a constant pressure, you need to reduce its temperature to reach the saturation temperature. Okay, so that is why this region is called superheated vapor. Similarly, if you take a region here, see, if you want to reach the saturated liquid, you need to increase the temperature. Okay, you need to increase the temperature. That is why these are called subcooled liquid. So that means you are raising the you need to heat it to reach the saturation temperature. So that is for a subcooled liquid at constant pressure, you need to increase the temperature to reach the saturation temperature, right? So this is the difference between subcooled liquid and superheated vapor. Similarly, here you have this side you have the rarefied gas. That means it existed. Here you have the compressed gas. Here you have the compressed gas. So that means rarefied gas means it that exists at a pressure lower than that of its saturation pressure. And similarly, compressed gas means it exists at a pressure higher than that of the saturation temperature. So that point need to be kept in mind, that is pressure is less than saturation pressure, and compressed liquid pressure is greater than the saturation pressure. So here superheated vapor temperature is less than the is greater than the saturation temperature, and here subcooled liquid temperature is less than the saturated liquid. Okay, and this difference T minus T saturation is called degree of subcooling. Otherwise, for a superheated vapor, this is the degree of superheating. So this is better, you can write this as T saturation minus